vector space classification. In this lecture, I will consider vector space text classification and basically Rocchio text classification. In vector space classification, we represent the document as a vector space representation model. In vector space representation model, we basically represent entire document in the form of row and column. Here each row represents entire documents and each column represents words. Now in vector space representation, we will do some extra thing like we represents word and their TF-IDF score. Similarly, word 2 their TF-IDF score, word 3 and their TF-IDF score, and so on. Similarly, in row 2 we will use document 2 their word, first word their TF-IDF score, second word their TF-IDF score, and so on. This is the traditional vector space representation. Now we will go through some important points like training set. Earlier in document clustering, which is actually the unsupervised kind of algorithms which do not require prior information of any kind, but in classification is a supervised algorithm. Here we use some information like set of documents with their label or class. For example, here in this picture, all red circles represents the document related to government. All blue circles represents the document related to science, and all black circles represents the document related to arts, and so on. This is the requirement for text classification. We initially have such kind of information. In a vector space classification, this set corresponds to a labeled set of points in the vector space. We will have a vector space like for level 1 we will have vector space with word and TF-IDF representation, and so on. Now we will go through two premises. Premise 1 says that documents in the same class form a contiguous region of space. Means there may be a distinct boundary which represents one class at one side and other class at other sides. Means the premise to clear it, the documents from different class don't overlap. Means we cannot put documents represented as a blue circle in the class which represents the documents related to red circle, and so on. This is a general vector space representation. Now suppose we consider this representation. Suppose a document represented by arrow comes, then how to classify this? For this there may be several techniques, but in this Rocchio classification what we will do, we will calculate the centroid of entire document collection and check whether this document is similar to this class, whether this document is similar to this class, or whether this document is similar to this class. Here a definite boundary is depicted, and we put this document into the class which represents the documents of government type. Now the next important part is dimensionality. we can reduce the high dimensional data. Actually, dimensionality is a major problem with documents, because in this kind of vector representation there may be some documents with very high number of words, some documents with very few words. Then it will create the gap of dimensionality, or for a fast running of classification we need to reduce the dimensionality of the system. Then we will use the concept of projection. For example, using projection of handle 2D and 1D graph. Now suppose 5 points x1, x2, x3, x4 and x5 are pointed in a circle. Now we can 2D circle, we have to project them into a line, 1D line. To project projection means this projection will not affect the relative distance between the points. For example, it will not affect the relative distance between x1 and x2, x2 and x3, x3 and x4. However, we cannot maintain the same distance between x2 and x3, but relative distance will preserve at some extent. Here distance doesn't means the distance between x1 and x2 like that. Here we consider the arc distance like this. So this is the representation of points, and here in the form of circle, that how we can represent the points into less dimension. This is the corresponding projection of 3D hemisphere into 2D plane, 2D circle. This is the projection of a points on the circle on a line. This is a projection of 3D hemisphere into 2D circle. That's why by using similar way we can apply the projection technique to reduce the dimension. Now the Rocchio text classification. How it works? First, the term is relevance feedback. Two class relevance versus non-relevance document. Methods can be adapted for text classification. Means whether the documents are relevant for that class or not relevant for that class. We can use Rocchio text classification, use TF-IDF weighted vectors to represent the text documents. For training in each category, it computes the prototype vector by summing the vectors of the training documents in a category. Finally, it calculates the centroid and then assign a new text documents to the category with the closest prototype vector based on the cosine similarity. Now first we will go how it works. Suppose in this set of documents, first we will learn what is the cosine similarity. Basically, cosine similarity measure is used in calculation of similarity between two documents. Here we will go through some very simple example how it can calculate. For example, to calculate the cosine similarity between document D1 and query Q represented as angle θ1, how can we calculate? This is a document D1 where 2 is suppose 2 is the TF-IDF vector score, TF-IDF score of term T1, 3 is the TF-IDF score of term T2, and 5 is TF-IDF score of term T3. Actually, it is not TF-IDF score, it is just maybe representation frequency representation of terms, but it will work in the same way if we use the TF-IDF. Here in query Q, number of term T1 is 0, number of term T2 is 0, but two terms matches with T3. So here wij into wiq for I is equal to 1 to t, and similarly here wij whole square into wiq whole square. Wij into wiq. Actually here wij, here it will be w1, w2 and w3, and wi1, w1, i2, wi3, wq1, w2. Okay, sorry. Here wij, actually only one word, only one term match, so wij will be 5, which represents which match with two terms of query q. So here it will be 2. Now suppose here score is more than 0, like 4, then we can add some extra term, sorry, not here, earlier, like 3 into 4, like that. So but here not it is so, because here it is 0. Now the denominator part, we can wij whole square means the term frequency scores whole square of all terms frequency. For example, here it will be 2 square plus 3 square plus 5 square into wiq whole square, as it is 0, 0 and only 2. So 0 square plus 0 square plus 2 square and whole root. This will be equivalent to this, and this is equivalent to this. After that we will get this calculation result. Now suppose here we use 4 instead of 0, then we'll make some change, like here 4 square, and here we will include this part also. So after that 22 divided by some other amount, like 4 plus 9 plus 25 whole square into 16 plus 4, and after calculation we can get this angle. So this is the general trend to calculate the angle. By using same way we can calculate the cosine angle between two documents, and so on. Now how to apply the Rocchio classifier. Now suppose this is a red document, so red circle represents the document government, blue circles represents the document science, and black circle represents the document art. What we will do, we will calculate the cosine angle of all the documents with respect to itself, and then calculate the centroid of that cosine angle. Similarly, we will calculate the Similarly, we will calculate, suppose this is a cosine angle. Similarly, we will calculate the cosine angle and their centroid for all blue documents. Similarly, we will calculate the cosine angle and centroid for all documents represented as a black color. And after that, suppose new documents come, for example this, then we will calculate the cosine of angle between this centroid and this document. If similarly we will calculate the cosine of angle with this centroid and this document, similarly cosine of angle with this document with this centroid, and check which one is the shorter, then we will decide that the document will be more similar to that document's sets for which the cosine angle is the shortest. Here it is most similar to the red documents as it is depicted here. Now it will clear from this example also. For example, this vector called prototype vector represents the red documents. Red prototype vector represents the red documents. Blue prototype vectors represents blue documents. This is the centroid for all prototype vectors. For that what we will do, we calculate the sum of angle of all red prototype vectors, then calculate the centroid. I use the same method to calculate the centroid for blue vector. Now suppose a new document came represented as a black vector, then we will calculate the cosine of angle with respect to red centroid and with respect to blue centroid of the blue vectors. Now as it is smaller, so this black document will be the documents represented as a black vector will be the part of blue document set. Now this is the training phase. Training phase is same. Suppose we have given set of categories and n is the total number of documents. This is the initial prototype vector, and for each training example where x represents the document and cx represents the class for which the document belongs to, and let d be the frequency normalized TF-IDF term vector score for document x. Here frequency normalized TF-IDF score means we normalize the TF-IDF score in each document by dividing the entire term frequency of every term in documents by total number of terms in that document to normalize that data into the form of 0 to 1. Now let I is equal to j while cj is equal to cx. Now we will calculate the proximity vector sum, and then we use this to calculate the centroid, and we use this centroid related information in classification of next document in the case of text page. For any given document, text document x, for here let d be the TF-IDF weighted term vector of given document x. Then what we will do, we will calculate the cosine similarity of given document d with pi, and if it fixes some threshold or class level, then we will put that document into the given class and update the most similar class prototype. But there are some problem. Just reread this line. Here we update the most similar class prototype, which are the main cause of problem. Here prototype models have problem with polymorphic or disjunctive categories. For example, here documents are not clusters are not contiguous. or classes are not contiguous. For example, here right side you will see some red documents, sorry, left side you see some red documents, right side again see some red documents, in between there are some blue documents. So in case of classification it may create problem. See how? Now suppose this is a red centroid of all red documents, this is centroid of all blue documents. Now this is black document, these are the angles with blue document and red document. And this black document shows more similarity with respect to red document centroid, while it is more similar to, in practical it is more similar to that blue documents, but due to the centroid concepts it shows more similarity with red documents, so it creates some anomaly in final classification. Some properties of Rocchio classification. Actually, the boundary between two classes in Rocchio classification is the set of points with equal distance from two centroids. For example, this is a centroid represented as star, as a rectangle, and as a cross. Now A1 shows the distance from centroid with the document set represented by rectangle. A2 represents the distance of class boundary from the centroid, which contains the classes which contains the document sets represented by cross. Here A1 will be same as A2, B1 will be same as B2, and similarly C1 will be same as C2. This type of representation is generally called as Voronoi diagram. The generalization of m-dimensional space. We can generalize m-dimensional space through this equation, w to the power t x is equal to b. Here, for example, for two-dimensional plane we can write the equation like w1 x1 plus w2 x2 is equal to b. For three-dimensional plane we can write w1 x1 w2 x2 w3 x3 is equal to b, and so on. The boundaries of class region in Rocchio classification are hyperplane. The classification rule in Rocchio is to classify the points according to the region it falls into. Some important points in Rocchio classification. Rocchio form a simple representation for each class, the centroid prototype. Classification is based on the similarity to the distance, similarity to or distance from the. Here we have seen the examples on similarity based on cosine similarity, but we can use the distance based measure. For example, we can use Euclidean distance or Manhattan distance to calculate the distances. It doesn't guarantee that classification are consistent with the given training data. We already seen some anomalies with Rocchio text classification. It is a little used in outside the text classification. It has been quite effective for text classification, but generally worse than naive-based classification. But the main thing is it is very cheap to train the and text documents. For example, we just need to calculate the centroid of documents, and there is very simple. That's why the training phase is very simple, and we can easily classify the documents. Thanks.